A warm welcome to my presentation, everyone. My name is Jorge de Heuvel and I conduct my research at the Human and Robots Lab at the University of Bonn in Germany. Robots should be personalized, and let me tell you why. Robots should be personalized because users may have personal gold standards about the interaction. So imagine closely collaborating with your personal robot at home or at work, and ideally the interaction should be as comfortable and natural as possible. So users may have individual preferences about how the robot traverses their home or how they actually approach. And here, personalization is a key factor. So today we talk about the preference alignment of robot navigation behavior. In this work, we learn a preference-reflecting navigation controller that relies mainly on depth vision. Using a virtual reality interface, the user intuitively demonstrates preferences by drawing trajectories right onto the floor using a handheld controller. To learn, a TD3 reinforcement learning architecture is used with an additional behavior cloning loss on the actor. And furthermore, a separate demonstration buffer is used that provides the agent with demonstration trajectories throughout the entire training process. The robot-centric state space captures information about the position and presence of the human in the robot's field of view, and also the goal position is provided. Most importantly for 3D scene understanding, the low-dimensional latent representation of the robot's depth camera is included. And then the perception pipeline consists of a variational autoencoder. It compresses the depth image to a latent space of dimensionality 32. And below you see input and output, so reconstruction of the variational autoencoder. To demonstrate, the user draws preferred trajectories onto the floor in virtual reality. The user's dynamic motion is here also recorded. And then later on, the demonstration data is used in the learning process. Let's look at the qualitative performance of the controller. The robot has to avoid the dynamic human denoted in red on the plot, while navigating from the start, that is a black dot, to the goal, that is a blue star, ideally along the demonstrated preference, and that is the orange line. In the couch scene on the left, the robot should navigate at the opposite side of the room, ideally like along the cupboard. Around the suite in the middle plot, the robot should take a wide turn around the armchair to make room for the approaching human. And in the entrance scenario on the right, the robot should take a left-hand turn while the human passes along. Let's get a better understanding by looking at the animated map. Right, a visualization of the robot's perception is shown. And we can conclude here that the robot successfully reflects the demonstrated preferences on its way to the goal. For further quantitative results and ablation studies, you're kindly invited to have a look at the paper on the workshop's webpage. To conclude, we demonstrate how to learn a preference-reflecting navigation controller that relies on depth vision. For further discussion, feel free to get in touch with me now or after the workshop. And the QR code provides all of my contact details. So I would also like to take the chance to invite you to have a look at our websites for more research.